All right, here are the answers to the last three problems that I worked, and each of these answers are for an acidic solution. Let's make it basic. So in this first equation, I have two hydrogen ions, and so if it's going to be basic instead of acidic, I need to neutralize those hydrogen ions. I do that by adding, there are two hydrogen ions, so I'm going to add two hydroxide ions to that reaction. Now, just like in algebra class, I can add anything I want to a reaction so long as that thing that I add, I also add it to the other side. So if I add two hydroxides to this side, I must also add two hydroxides to the products. These two hydrogen ions and two hydroxide ions are going to come together and they're going to form two H2Os. And then these hydrogen ions over here are just going to hang out. Since I have now two waters on the reactant side and one water on the product side, this water will cancel with one of these waters. So then in my final basic answer for that reaction, it will be one water plus the two nitrates plus three SO3 minus 2s makes two nitrogen monoxides. The waters have been canceled, three sulfate ions, and two hydroxide ions. And that would be my basic answer. And again, just like with the acidic answers we looked at in the other videos, this will be a properly balanced equation in terms of atoms and in terms of charge. And so as a quick check, we can just make sure the number of oxygens are the same on each side. So there's 2, 12, and 2. So that makes 16 oxygens on the product side. And then we have 6 and 9. That makes 15. One more, 16 oxygens on the reactant side. The total charge on the reactant side, you have two of these minus 1s and three of these minus 2s. So that's minus 6 and minus 2 for minus 8 on the reactant side. And then you have three of these minus 2s for minus 6 and two minus 1s, also minus 8 on the product side. So I would say this is a properly balanced reaction this is a properly balanced equation for that reaction. Let's take a look at this next guy. It's a little bit bigger. We have 34 hydrogen ions, so I have to neutralize each of those 34 hydrogen ions by adding 34 hydroxide ions. Those 34 hydrogen ions and 34 hydroxide ions are going to come together and form 34 water molecules. Since I added 34 hydroxides to the reactant, I am also required to add 34 hydroxides to the products. They have nothing to combine with, so they're just going to hang out as 34 hydroxide ions. These 34 waters in the reactants and these 17 waters here in the products are going to reduce out. So 17 of them didn't do any chemistry. 17 of them just jumped the arrow. So I can get rid of 17 on each side, leaving behind 17 waters. So there I have 17 waters plus 5 Cr. I'm guessing that should be dichromate. Did I write that wrong in the first place? So dichromate ions plus 3 iodines make 10 chromium 3 ions plus 6 iodates and our 34 hydroxides. And let's check that to make sure that it is properly balanced. We have, let's see, 5 sets of 7 oxygens there, so that's 35, and then 17 oxygens in the water, so that adds up to 52 waters on this side. And then over on the product side, we have 34 there, 34 from the hydroxides, and then 6 sets of 3 in the iodates. So that's 18 and 34, also 52. So our oxygens check out. And let's see, in terms of charge, we have -10 on the reactant side. And then on the other side, on the products, we have -34, -6, and then +30. So the +30 and the -34, that's going to leave us with -4. -4 with -6 gives us -10. So there we go. Checks out in terms of oxygens, checks out in terms of charge. So that guy is good to go. And then lastly, down there at the bottom, let's make that one basic. 6 hydrogen ions. So by now I think you've kind of got the rhythm to it. We're going to need to add 6 hydroxide ions. We add those 6 hydroxides, they're going to neutralize those hydrogen ions and give us 6 water molecules. There are 6 waters on the reactant, 3 waters on the product, so get rid of 3 on each side. So that leaves us with just 3 H2Os on the reactants, and then we add everything else up. Now, since I added 6 hydroxides over here on the reactants, I am going to need to add in 6 hydroxides there on the products. That went off screen, didn't it? Add 6 hydroxides here on the products. So we have our 3 waters plus our 4 CrO3s plus 3 seleniums yields 4 Cr plus 3s, no waters because we reduced those away, 3 SeO3s minus 2s, and 6 hydroxide ions. Then let's check that guy out. There are a total of 4 sets of 3, so that's 12, plus 3 more oxygens there, so that's 15 oxygens here on the reactant side. You have 6 in the hydroxide and 9 from the SeO3s, so that is 9 and 6, 15. So 15 oxygens on the reactants and on the products. And in terms of charge, this whole side is neutral, so let's hope that other side is neutral. You have 4 positive 3s, so that's positive 12, 6 negatives, so that gets us to positive 6, and then 3 minus 2s, that's negative 6. So yeah, both sides come out to have a charge of 0. So this is definitely the right answer. All right, so I hope that helps with turning an acidic half reaction balancing problem into a basic solution. So, all right,